another complex circuit. Right? Let's say we have a 24-volt battery. We have a 24-volt battery. And then I've got, let's keep it relatively short here for the first one. I have 3 resistors in this circuit. 3.4 ohms, 7.9 ohms, 8.2 ohms. Just for argument's sake. Just for argument's sake. And I want you to tell me, just from this, me giving you the voltage of the battery, what the current and the voltage drop across every last one of these resistors is, using Ohm's law and our rules for adding resistors. Using Ohm's law and our rules for adding resistors. So here's what you need to do to start out with. I said the reason that we use equivalent resistance, the reason that we add all the resistors out like we did with bell work, is to establish a simpler circuit that we can deal with in a very easy manner, right? Ohm's law, V equals IR, right? Deals with one resistor, we have to know 2 other things. And if we reduce down to one resistor and a battery, well, that's about as easy as it can get. You can apply Ohm's law straight to it. So step 1, whenever doing this, reduce down. Reduce down. So which 2 resistors do I want to add first? Yeah, parallel. Please do that for me really fast. And please redraw whenever you're doing this. So this is still my 3.4 ohms. Right? Still my 3.4 ohms. This one over here I did 1 over RT equals 1 over 7.9 plus 1 over 8.2. And so what's that resistance there? Say that again, please. 4.02. Let's keep all of our significant figures to the very end. 4.02 ohms. Next, what do I need to do? Add them in series or parallel? Series, right? And then I'm going to be down to my simplified circuit, right? So battery, simplified circuit, 4.02 plus 3.4 equals 7 point what? Yeah, shame on you if you use your calculator. In fact, don't raise your hand. In fact, let's raise our hands the other way. How many of you did not use your calculator? Oh my gosh, guys. Look. On that one. You did not need your calculator on this one at all. Trust your math skills, please. You do math quicker than a calculator, believe it or not. You do math quicker than a calculator, believe it or not. Now, in this simple circuit, I have a battery and I have one resistor. That means all of the voltage is going to drop across that one resistor. Remember that? All the voltage drops across that one resistor. Meaning the only thing I don't know about this circuit is the current, which I can solve for. Correct? Which I can solve for. This is just Ohm's law now. V equals IR. 24 equals I times 7.42. I equals what? What's the total current coming out of this battery?
320.
Give me that again, please.
3.
Sure, why not? 3.24. What unit goes with current? Amps, capital A. Amps, capital A. Now, this is for the equivalent circuit. I didn't ask for what is the equivalent circuit current, right? Or just the equivalent resistance. I asked for, please give me the voltage drop and the current through all of those original resistors. So what we're going to do is we're going to work backwards, using our rules that you wrote down, and I emphasize that you had to write down. So I mean, let's come back over. Let's go to a different sheet, and let's parallel, not 11, parallel, mathematical symbol, right? Two parallel lines. Parallel. What are the 2 things? What stays the same? Voltage stays the same. Current does what? Divides. Current is going to split up. right? Parallel, voltage remains the same, current splits up. In series, what stays the same? Current stays the same, and what divides? Yeah. My voltage divides. Okay? Now those little rules are what we're going to use, and we're going to work backwards through this entire subject. Coming all the way down to the bottom where we were. And working up. One series. This is why you have to redraw every single step of the way. This is why you have to redraw every single step of the way. Working up one notch. Those two resistors are in series or parallel? Series, right? One step up. Those two resistors are in series. What stays the same in series? Current, right? So what I can tell you is the current going through each of these guys is going to be 3.24 amps. What is the one thing I don't know about each of those resistors? Voltage, right? I don't know the voltage that's going to drop across them. How do I calculate it? Ohm's law. Ohm's law for each individual resistor. So for this guy over here, apparently decided to jump on me. V equals IR, right? V is going to equal my 3.24 times 3.4, right? You getting this down? This one over here, V equals IR. V is going to equal 3.24 times 4.02. So please give me those voltages. What are those voltages? Which one are we talking about, please? First one, up here, 11 point what? 016, we'll use 02 volts. And the next one? Voltage divides in series, current stays the same. Those two voltages add back up to be approximately 24 volts. Does that make sense to everybody? It divided up into these two. Now it didn't split equally, it splits by how large the resistors are, right? So it's going to sum back up to the total. It's going to sum back up to the total. All right, so now I have everything in this circuit. I can actually go up to one more level, which is my main circuit. Now, this 3.4, I already know everything about. I know R. I already know I. And I already know V. We're going to have to go back and modify those numbers for significant figures. Okay? But that 4.02 ohm guy broke apart. Do you see what's happening here? Those of you who are visual, I mean, actually think about this 4.02 guy over here at the very end, actually splitting up in two, right? Actually splitting up in two. Into, is that series or parallel? Parallel. What stays the same in parallel? Try again. Voltage stays the same in parallel. Current divides. So what that means is I can carry the voltage up. The voltage here is going to be whatever I found. 13.02. The voltage here, 13.02. What am I missing of those two resistors? Currents, right? Currents. So let's solve for I. For this guy, 13.02 equals I times 7.9, right? This guy over here, 13.02 equals I times 8.2. So solve for me those currents. 1.34 amps. And the next one, I equals 1.5 approximately. 1.65. 1.6 approximately, okay, 1.6 amps. Once again, check out current divides, right? 1.34 plus 1.6 is getting you close back to, remember, this is math here, we're throwing away some significant digits, getting you close to your 3.2. Sum back up to the total.
I got 1.6.
Yeah, I got 1.6.
1.6 would make a lot more sense there, wouldn't it? You should get 1.6, you're getting 1.6 for both of them?
I got 1.5.
1.6 would make a lot more sense here. Why? Why? It's got to add back up to the total, thought 1. It's got to add back up to the total, thought 1. Thought 2. Check out the resistance. How close are those resistances to each other? Pretty close. So the currents going through them should be really close too, right? This is what I've been trying to pound into your heads time after time after time. Do not turn off your brains, right? Keep kind of a physics idea. Your calculator might spit out the wrong answer, right? You might have typed something wrong. So both of those about 1.6, probably the 7.9 is going to have a 1.61, and the 8.2 will have a 1.59, something along those lines. Now, I've got everything that I need. Here's the answers for these resistors. Here's the answers for that resistor. There's the answers for the final resistor. You collapse all the way down. You collapse all the way down, and then you expand all the way back out. Collapse all the way down, and then expand all the way back out. Okay.
What would the question be for this problem like this?
Problem like this. Let me give a more practical question that you're going to work here in a second. I have a power source. Let's say it's an AC/DC adapter, right? So I'm taking the wall voltage. I'm actually going to hold it at 120 volts, kind of rare. I'm going to hold it at the 120 volts, right? Very rare. Coming out, and I'm going to put that into a circuit. I want you to tell me what voltage drop goes across my load. Now, the load generally refers to the item that I care about. The item that I care about. Whether it's a light bulb, whether it's an electric motor, whatever it is that I really care about the end. But it's in a complex circuit. So for all practical purposes, I have a battery set at 120 volts. And I have a circuit that looks like this. Our load. The load is going to have a resistance of 120 ohms. We're still dealing with basic little ohms, little teeny tiny resistors here. We're going to get relatively large current. Okay? Just numbers here. Oh, let's give ourselves 32 ohms here. 56 ohms there, and 39 ohms there. And I want you to find for me voltage drop across our load. Find for me the voltage drop across our load. The only way you're going to be able to pull this off with what I've taught you so far is collapse all the way down, and then expand all the way back out. Now, I got to add all the way down to get an equivalent resistance. The idea behind that is you can't just look at this circuit and then use Ohm's law to figure out what the voltage is across it. You don't know the current through it. You don't know anything about that resistor besides in what combination he is with other resistors, right? And the battery that through this combination he's hooked up to. But specific things about that resistor, all you know is the resistance, right? So I need to combine all the way down to an equivalent resistance. The first step here, come up here and actually look at what I've got. I'm going to combine those two in series, right? giving me 120 plus 56. Please don't use your calculator. 176.
My calculation says 175.
Please don't use your calculator. 176. Okay? Next, we've got a 32, 39. What's the next most obvious one to do? Parallel. Which two are in parallel?
176 and 36.
Good. So that's going to get me down to, not simple yet. I'm not going to worry about doing the math for you. I feel like you're pretty good at that right now. Adding those two in parallel, what'd you get? 27.1. 27.1 ohms, approximately. Right? You came up with 27, 27.2, whatever. Now, simple circuit. Those two final resistors are in what? Series or parallel? Series. Add them together without your calculator. 66.1 ohms. Now I start working backwards. What's the one thing I do not know about this simple circuit? Current. Right? So V equals IR. That's 120 equals I times 66.1. Gives me a current of approximately what? 1.81. Thank you. 1.81 amps. Now I'm working back up, step by step by step. One step up, I took this guy, right, 66, and I'm breaking him back into, is that series or parallel?
Series.
What remains the same in series? The current. So each of these has a current of approximately 1.8 amps in them. What's the one thing I don't know? The voltage. By the way, I'm going to be a little bit more targeted here. That 39, he has nothing to do with my 120 ohm load, right? It has nothing to do with it. I'm not even going to solve 39 because I don't care about it. Okay? I don't care about it. I'm going to be a little bit more targeted. I care about this 27, right? So this is going to be a V equals IR, again, Ohm's law. Specifically, I'm looking for the voltage here, the current 1.81 amps times 27.1 ohms, right? And that gives me a voltage of what? 49.1, approximately. 49.1 volts, approximately. Now I'm going to go another step. That 27 gets broken apart into the 32 and the 176, right? In series or parallel? Parallel. What remains the same in parallel? Voltage. And which of these two resistors do I care about? The 176. The 176 is a combination of my 120 and 56. The 32 has nothing to do with it. So I'm being a little bit more targeted here, right? I know the voltage across this guy. The voltage drop is going to be about 49.1 volts, leaving me to calculate what? Current going through him, V equals IR, Ohm's law. That's going to be 49.1 equals I times 176. What did you find your current to be? 0.27 amps?
Yep.
Okay. Last step. Coming all the way up to the top, right? I take that 176 and I break them apart to my 120 and 56. In series or parallel? Series. What remains the same in series? Current. Current. That means that the current flowing through this guy over here, through the resistor I care about, is 0.27 amps. And that's going to let me get to the final answer that I want, the voltage drop across my load. So, V equals IR, V equals 0.27 times 120. What is the final answer I'm looking for?
32.4.
34, 4-1.
Tomato plot. I'm hearing somewhere around 33 volts. Give or take. There, give or take, depending on how many significant figures you kept in your calculator working all the way through. Okay. About 33 volts, depending on how many significant figures you kept in your calculator working all the way through. Questions? Go at it.
When are you gonna check this?
Soon. Other questions? Yes, you will have a lab. In fact, let me go ahead and talk about the lab. The lab's going to look something like this. You're going to set up Wednesday. You're going to set up Wednesday a complex circuit, resistors in series and parallel and all over the place. You're going to get the voltage of the battery and the resistance of each of those guys, and that's all you're going to get. And then you are going to mathematically, on paper, figure out what the voltage drop across each resistor and current through each resistor should be, just like we did here. And I'm going to come around with my multimeter, and I'm going to randomly point at all the resistors and say, tell me the current through this guy. And it's going to be right or wrong, right? You either got it right, you got it wrong. Your circuit's going to be required to have 6 resistors in it. If you get all 6 right, there's your 120. You get 5 right, that means you made some of the movement in there. You get a 100. Be very careful with your measurements, by the way, in the beginning. You get 4 right, that's an 80. Less than 4, that's bad. Okay? That's bad. I don't expect anything less than that. Homework is already on the board over there. Please write it down on the whiteboard.